In this presentation, we will see about the adulterants that are present in common food items like milk, meat, oil, ghee, and spices like chilli powder, turmeric powder, asafoetida, etc. Here we will see about the types of the adulterant that are there, its detection method, and its impact on health and quality. First, we will see about the adulterant that are present in milk. So, first adulterant will be water. Water presence can be detected by lactometer test. How means it shows the density. So, if water is present, then the milk will have lower density. So with the density value, we can see using the lactometer, we can see whether water is present or not. Next adulterant that can be present in milk will be detergent. So if we add alcohol, froth will come, like a foamy reaction, froth will come. So we can understand that detergent is there. Apart from this, starch and urea can also be there. So starch present can be indicated by iodine. So iodine with starch will give blue color. So we can understand that starch is present. And urea presence can be indicated with para-dimethyl aminobenzaldehyde, DMAB. Para-dimethyl aminobenzaldehyde. So this reagent will give yellow color if urea is present. Apart from that, if the cow has been administered with some antibiotic, the milk will also have that antibiotic. That presence could be detected by spectrophotometer. Next, we will see the adulterant that are present in meat. So the common adulterant will be sodium nitrite. It is also used as a preservative. So in order to preserve meat for a longer duration of time, or that processed meat and all, like sometimes the one patty used in hamburger, like that they can use this sodium nitrite to preserve the meat, and not only that, it retains that pink color of that meat. How it retains that? It does this reaction. This amino group present in the muscle with the sodium nitrite will give nitroso compound, which is carcinogenic. It is not good for health. So how it can be checked is, it can be detected by solvent extraction and also using U visible spectrophotometer. Next is the adulterant present in coffee powder. The main adulterant is chicory. Chicory, that from the root we get that chicory. It is added in the coffee to give the strongness. So its presence can be detected by Selivanov reagent. Selivanov reagent is nothing but 0.05 gram of resorcinol in 100 ml of hydrochloric acid. So if chicory is present, a faint red to deep red color will develop. Another adulterant can be starch. As we've seen earlier, it can be identified using iodine solution. So directly we cannot use iodine solution because the coffee itself is like brown color. We cannot see any blue color in that. So first it is decolorized by adding, the coffee extract is decolorized by adding potassium permanganate, and after that if we add iodine, we can see the formation of blue color, and we can know that starch is there. Next, the common adulterant in coffee powder is tamarind seed powder. It is also brown color. Coffee is also brown color. So the coffee seed is costly, so they will mix it with tamarind seed. That is the adulterant there. So how can we detect it? We can detect it by spraying 1% sodium carbonate over the coffee powder. So we can take a blotting paper, and in that paper we can have the coffee powder. Over it we can spray the 1% sodium carbonate. Then it will, the blocking paper will be turned to red, which indicates the presence of tamarind seed powder. Next, we will see about the adulterant that are present in oil. So iodine number will give the It is nothing but number of gram of iodine that will add to 100 gram of fat or oil. So what does this iodine value indicate is the number of double bond or the degree of unsaturation of the oil. So the more unsaturated it is, the more good the oil is. Next is Richard Meitzer number is another number. It is the number of milliliter of 0.1 m potassium hydroxide solution required to neutralize 5 gram of fat. So what it does indicate is it indicates free water soluble fatty acid that are present. Next is Polanski value. It is the number of milliliters of 0.1 N aqueous sodium hydroxide required to neutralize water insoluble fatty acid. So Richard Meitzer number will give you the water soluble fatty acid value, and Polanski value will give you the water insoluble fatty acid value. So this value indicates that the amount of fatty acid present, and the amount of iodine number indicates the amount of unsaturation that are present in the oil. Next is there can be some other oil that can be mixed in another oil. For example, if we purchase sunflower oil, it can be mixed with castor oil also. So in order to check the presence of this oil as adulterant, we can perform this test. So to check the presence of castor oil, if we add 1% sodium ammonium molybdenate in sulfuric acid, turbidity will develop if castor oil is present. So in order to check sesame oil, we have to add 2% furfural solution in alcohol. In the presence of concentrated hydrochloric acid, a permanent pink color will develop. In order to check for mineral oil, this is mostly present in many oil. This mineral oil can be there. So they say, most of them they say this oil won't be pure because mineral oil adulterant will be there, like sunflower oil and all. So many sunflower garden is not there, like that people used to say. So how to check the presence of mineral oil is, we can take the oil in alcohol with a flask fitted with a condenser, and we can boil it in a water bath, and after that the solution is cooled, and to this water is added, and if turbidity develop, we can identify the presence of mineral oil. So the amount of turbidity will give you the intensity of the amount of adulterant that are mixed. Next is the test for groundnut oil. So in order to check the mixing of groundnut oil, the groundnut oil is having this arachidic acid. So an alcoholic soap solution will give a precipitate on a treatment with dilute acetic acid or hydrochloric acid. So this test can be performed to check whether groundnut oil is present. To test the presence of poppy oil or argemone oil, we have to treat it with ferric chloride. When we treat with ferric chloride, needle-shaped brown crystal will be produced. And another test is also that with dilute nitric acid, it will give red color. And then this argemone oil is not good for health also. It will cause swelling of limb, and it cause pain in the eyes. Sometimes it can lead to blindness also. And this argemone oil or poppy oil can cause cancer also. So this oil adulterant must surely be avoided. Next is cottonseed oil. So this oil will give red color with a solution of sulfur in carbon disulfide. Next is linseed oil. It forms precipitate with bromine in chloroform. Next is allyl isothianate. So this is allyl isothianate is not another oil. It is compound, a chemical substance. So it's an organic compound actually. For this can be added to enhance the taste of the mustard oil. So this can contain a high hydrocyanic acid as impurity. So how to test this is, we can blow oil through the heated oil, and it is absorbed by sodium hydroxide. The HCl liberated by the heated oil is absorbed by sodium hydroxide and forms sodium cyanide. So on adding ferrous sulfate and a drop of ferric chloride, blue or bluish green color precipitate will be formed. So we can identify the presence of allyl isothiocyanate that is present in the mustard oil in order to enhance its flavor. Next, we will see the adulterant that is present in ghee. So sometimes ghee can be adulterated with oil. So how to check it is very easy. We can keep it in the freezer. If it is pure ghee, it has to be solidified. Fully it has to be solidified. But some liquid part is there, means it is mixed with oil. Next, it can be adulterated with that dalda vanaspati. So how to check it is, the melted ghee is mixed with equal quantity of concentrated hydrochloric acid with a pinch of table sugar and shake well. After that, a crimson red color will be developed if vanaspati is present. Next, ghee can be also adulterated with starch, like mashed potato can be added the ghee. So the starch presence can be indicated with iodine with a blue color. And next, good quality ghee should have only small amount of fatty acid, as fatty acid indicates oil. So it should not have more fatty acid. But if that ghee ages, it gets hydrolyzed to oil, that is the free acid. So it can be checked by the richer meat cell value and Polanski value, as we have seen this earlier in the oil checking test. So richer meat cell value gives the water soluble fatty acid value, and Polanski value shows the water insoluble fatty acid value. So the richer meat cell value should be less than 28 for a good quality ghee, and Polanski value should be 1 to 2 for a good quality ghee. Next, we will see the adulterant that are present in butter. Butter can be adulterated with lard. It is the fat of pig. Okay, so this can be found out by finding its iodine value. So lard has that pig fat is having higher iodine value than butter. So 30 to 40 is the iodine value of butter, but the lard iodine value is 46 to 70. So with this checking the iodine value, we can see whether lard is present or not. Butter can also be adulterated with starch. So starch test is, it should give blue color with iodine. With that we can identify. Next we will see the adulterant that is present in our beverages, tea. So tea can be adulterated with dust, dried leaves, sawdust, black gram husk, cashew husk, tamarind seed powder. Okay, so the tamarind seed powder, you remember that sodium carbonate solution, 1% sodium carbonate solution spraying in a blotting paper. Same test we can do for tea also. Next, if it's like this dust, dried leaves and all there, means we can put it inside the water, and tea leaves are all generally it will float. So with that test we can identify whether tea leaves is there. Adulterant will settle at the bottom. We can find out using that test. So when you prepare tea also, you can easily see when we put the tea powder will float only, it won't go down. So next, tea can also be adulterated with gram dal husk. So for this, we have to keep this tea powder in a porcelain tile coated with slaked lime. Slaked lime is calcium hydroxide. So if we put like that, we should get red or orange color if coal tar is present. But if pure tea is there means we will get greenish yellow color only. Greenish yellow color only we will get. We will see now the adulterant that is present in asafoetida, Hing. So the adulterant that are present in asafoetida is nothing but foreign resin, ammonium, colorpony resin. All these can be added as adulterant in asafoetida. So how to identify it? So the sample, that asafoetida or Hing sample, can be mixed with water and it can be shaken. So if any earthy matter is present, it will be settled. It will settle down at the bottom. So, but the pure asafoetida will dissolve in water and form a milky white solution. So we can identify if any impurity is present or not. Next, the asafoetida powder, we should powder it, and then we have to shake it with alcohol and filtrate. With the filtrate, we can do the following test. So a few drop of 10% aqueous ferric chloride is added to the filtrate. We'll get olive green color if foreign resins are present. And in order to check the presence of galbanum resin, dilute hydrochloric acid is added to the filtrate. So faint turbidity will indicate the presence of galbanum resin. Next, if bluish green color develops and if it fades on standing, then also it indicates the presence of galbanum resin. In order to test the ammonium resin, so it is the filtrate is treated with freshly prepared sodium hypobromide. We will have the formation of red color to indicate the presence of ammonium resin. To test for the presence of colorpony resin, this filtrate is treated with acetic anhydride and concentrated sulfuric acid. Then we can see the color changes to purple, red or violet. So colorpony seed presence can be identified. So another test is also there to check the colorpony resin. The filtrate is treated with 5 ml of 0.05% copper acetate, and then we can see appearance of bluish green color. Next we will see for some spices like turmeric. Turmeric, what are the adulterants that are present? So in order to enhance the color of the turmeric powder, they will add yellow aniline dye, which is not good for the health. So on shaking with a small quantity of turmeric powder in water or in water with alcohol, we can see the yellow color coming out immediately. So we can identify the presence of aniline yellow. Next, lead chromate presence. This is another chemical which can enhance the color of the turmeric powder. But it is having a bad impact on health. It can cause anemia, that is iron deficiency, abortion, paralysis, mental retardation, brain damages also in children. So that it can be identified by adding dilute sulfuric acid and boiling for 5 minutes and then adding 2% diphenyl carbazide. We can get a dark pink color to indicate the presence of lead chromate. Next, another adulterant is metanyl yellow. This is aniline yellow is another dye, metanyl yellow is also another dye. So for this we have to take the turmeric powder and add a 5 ml of alcohol and few drops of hydrochloric acid. Pink color, if it develops, it will indicate the presence of the metanyl yellow dye. Next, in chilli powder, what is the adulterant that are present, we'll see that. So the finely grounded brick powder, they can be mixed with the chili powder. So when we do how to check it is, if in water, we can take water in a beaker and then we can add the chili powder. If brick powder is there, it will settle down. So the presence of brick powder can be found out easily. Another thing is by using a flame test with concentrated hydrochloric acid. If you heat it over a flame, brick red color will come if brick is there. Next, it can be contaminated with rhodamine B dye. Of late, there is a widespread news about it, which is used in cotton candy and all. Cotton candy, rose milk and all, this rhodamine B. This chemical can also be used in chili powder also. Some chemicals are banned all over the world of using this dye. So this dye is carcinogenic. It can affect kidney, spleen, liver, etc. So it will give orange color with hydrochloric acid. With that we can identify the presence of the rhodamine B dye, which is very bad for health. It is a dye actually. It will change color in different pH condition. Next, red chilies also can be adulterated. They coat this red chilies with red dye. So we can identify its presence by just rubbing it with a piece of cotton soaked in paraffin. So the dye color will get attached to the cotton and we can visually see that. Next is dal. Dal, the peas and all, they will add green dye for aesthetic appearance. So if we add ether, it will turn to green color, showing the presence of dye. Likewise, yellow dye can be adulterated with methanol yellow. Same test which we did for turmeric, we can do 5 ml of alcohol and concentrated hydrochloric acid. If we add, pink color will show the presence of methanol yellow. And then if kesari dal is used as adulterant, 50 ml of dilute hydrochloric acid, we have to heat our dal with that, and if kesari dal is there, pink color will come. Next, insect infestation can be there. So insect infestation infestations is there, uric acid will produce as a byproduct. So we can treat it with 1 drop of potassium cyanide followed by ammonium molybdenate solution. We will get blue color if uric acid from insect infestation is there. Thank you.